we are looking at the Java Food Pizza Planet, which is direct from Toy Story. You ever seen Toy Story?
Yeah, I get referenced on that one a lot.
Yeah, so that's where that came from. Pizza Planet. Okay, you can do whatever food ordering system you want. Point of sale food ordering systems are pretty standard cannon fodder for problems in programming, just because that's one of the things that programmers do some point. So based on the user's order, calculate the bill. We have the price of the pizza, we have the price of the medium pizza. We don't want to do what are called magic numbers. We want to have a constants, so we need some constants, which typically go toward the top. In this program, we do final. You can't enforce constants in Python, although it's a good plan to use constants, because when you're looking through the code and you're like 200 lines down or in some other thing, then you know what in the world it means, where $15 doesn't mean anything, right? So this would be the normal naming convention for every language I've worked with. What is it, 15? Yeah, 15. Oh, and I forgot to type it. So int is good. Doesn't need to be an int, but we're just going to deal with a few things. So this would be a constant there, Andy. I was in week 6. This is a constant. Final means it does not change. This is a naming convention. The reason it's a convention is programmers have just kind of used this way of naming constants. So everybody knows when they're looking through the code, oh, this is a constant. That's what conventions are for. So we need some constants for anything we know ahead of time. And then we would do maybe our variables, which would be things that change, right? So maybe the total cost. And in Java, the convention is to do the naming like that. And do we have to initialize total cost? No, we'll just make it a double. We can just leave it with an empty memory space, which just means it has junk in there because we're not going to use it until we put a value in it. Or you can initialize it as 0 if you wish. Either way is not going to affect the program. So far, so good, Andy?
So far.
Okay, so these are constants. These are variables. And this is the convention that's used quite often in Java. Just like every language has a convention of how they do things, conventions allow us to easily look through the programs and figure out what's going on. And I look at lots of programs. Now, here's something new. When we're doing our menus, we've been using numbers. Some people have figured out how to do comparisons of strings, which is interesting because we've not covered comparing strings yet. But when you're doing a menu system, instead of 1, 2, 3, 4, you can do a char. So what's a char? What data type is a char?
Character. Seems like just one letter.
Yep. So for instance, that's it. So when you're expecting somebody in the menu system, for example, to say menu A and you put the little A in parentheses and you type the A, you can compare this because this is a primitive variable. So there's 2 types of variables in Java. Hello, Andy. This is for you. Python only has classes for their variables, but you can treat them like primitive variables. And so a primitive variable in Java, C#, C++, all those types of languages means that you can compare them directly. There is no class. There are wrapper classes that we'll use later on, but double is a primitive variable, meaning you can compare a double to a double. Python does stuff in the background where it can compare all the classes. We can compare a character directly. So we can compare one character to another. To do strings, we have to use a dot equals method because the string is a class or an object. So far, we've only dealt with primitive variables, which is not really a concept in Python because it treats everything in Python as an object, but the background coding for Python allows us to compare them directly with this guy. So far, so good?
Okay.
So for instance, I'm just going to paste this code in because this is a new blue thing. Python does not have char because you can treat a string just like a character. Notice that there's a single guy there. Yeah, you have to use a single quote.
Shouldn't character 3 be C?
Oh, it could, but I'm comparing.
Oh.
To see
Okay.
if we can compare, primitive variables. And we'll see what the answer is. So this should come out with either true or false with each one of these, right? Because we're directly doing an evaluation of the truth.
Well, how does
Of
it do the
this.
second one when they don't have numerical values?
Ah, good question. Very good, Andy. Did you know that everything on the computer has a numerical value?
Ooh,
It does. Everything, including strings and everything, has a numerical value. Oh, what's the character map? So in Windows, I'm answering your question there, Andy. Why? I'm going to get you one of these days. So, for instance, we're typing in an exclamation point. There it is, 0021. That's the Unicode number that's behind it. That's what the computer sees, the Unicode number. So there's a big, so if we're comparing L, is L or C greater than N or E? It's a hexadecimal.
ooh,
So E is greater than whatever we're comparing it to, C. So this one is greater, L is greater, N is greater than L. So it's not comparing the character, it's comparing the numerical value that's behind it. And every character that we deal with has a Unicode behind it, even numbers. But they compare as numbers, but notice the Unicode 31, 32, 33, 34. Which is important to understand when we get to regex and some of those other things, which I haven't put in this class yet, but we do need to deal with that a little bit at some point. Anyway, so that's why you can compare these directly. A string you cannot compare directly because it's a combination of characters and it's a class in Java. And you can't compare objects directly because an object is, well, take a look at that. An object is, here's my primitive variable. When I declare it, the value is in here. That's where my value is. Oh boy. I don't know what that's supposed to be. Some sort of three-dimensional figure. When I declare an object, I have a pointer. It's not really a pointer, but you can think it's a reference to here's where the data actually is stored. So if I'm comparing one object to another, I'm comparing memory addresses. Where if I have primitive variables, the data is stored here, the data is stored here, I can compare those directly. That's the computer sciencey part of what we're working on today. Is the difference between but now, however, in Python, everything is an object. Python does stuff in the background that says, oh, well, you want to really compare these values. So it does stuff for you. And so Python is kind of like training wheels. It's good for fast prototyping. It's good for a million things because it's open source. Everybody's written a million stuff, but you're not always going to be programming in Python. As the guy said the other night, you're going to use all kinds of things every day. Just depends on what you want to do. So if we run this, which it should work, I'm missing all my, there it is. That's what I was missing. My little run button. Oh, I should allow. Because I haven't run anything on here. Oh, there it goes. So false, true, true. That's our truth table for this. False, because this character is not the same. This is one Unicode number higher than this one. And capitals and lowercase have different Unicode characters, Unicode numbers. It all started with ASCII, but there was a limited number of numbers for characters in ASCII, and we wanted to include all the languages, Russian, Spanish, whatever, and all their little accents and everything. So it was expanded by creating Unicode, which is an international system of everybody agrees that an A is 24 or whatever the number is. So that's kind of where Unicode came from, is we needed some way that no matter what the programming language was that we were using, we still had a Unicode character for whatever language we were in. Make sense?
yeah.
Okay, well, now we have a problem though. Let me bring this program in. There it is. So we can use this for a menu. If I can get the code here, we would. Oh, it's in Replit. Let's see if my Replit just took out a lot of their free stuff now. Those darn people. They used to use this a lot, but now they can only have so many REPLs and blah, blah, blah. Not naughty people. There it is. There it is. There's my replet. So Andy, we're declaring a character variable, char, menu choice. It's a variable. We're declaring, yeah, we do our scanner input. We're prompting the user. The other one we would do next line. But a character, we want to get a single character. So if you have multiple characters in a string, you have multiple, you can think of it like multiple characters. So a string can somewhat be treated like an array. So you have a 0 position, you have a 1 position, you have a 2, 3, 4. We want the first character typed in. Is the reason it has character at 0. We're taking the first character typed in. In fact, it'll probably blow up if we type in 2. Because we just want a character, one character. Now, people will, even if they're prompted like this, they might type in an uppercase, they might type in the lowercase. Well, as we just found out, those are 2 different Unicode numbers. They're not the same thing. So a common way to take care of that with strings or characters is to convert it to a lowercase. So then you can compare apples and apples. You can do A's and B's. And so in this case, oh, now we're getting deep. Are you ready for deepness? The character is a class wrapper around this variable. It's a wrapper around the primitive variable. And how do I know that? Because it has .2 lowercase. You have .2, .next, whatever after something, and that indicates it's an object with methods. Here we're not declaring an object, we're using it directly from the wrapper that goes around it. So you can use characters directly. You can use methods that Java has created to make it easier to work with characters. That's why they added that in. Python does all this in the background for you. It gives you training wheels. Now that's pretty deep, isn't it? Let's see. Oh, I can't even run my own thing. I know that's part of it too. Even if I'm logged in, I can't run my own deal anymore. Yeah, I used to have I have to fork it to run it. What happened to my run? Yeah, they changed something on me. Anyway, I'll copy this into the code and we'll try it. Yeah, I'm very disappointed in Replit. I have to find somebody else. There's lots of pre-compilers. Okay, it said I had trouble. Uh-oh. Okay, so, oh, what do I have wrong with my program here? Menu choice, it's menu choice. Okay, it renamed it when I pasted in the code. Visual Studio Code is smart sometimes. Oh, there it is. It was in the middle of renaming it. So if I type in 1 character, I get the menu choice N. What do you suppose is going to happen, Andy, if I type in 2 characters?
You only get 1.
I had only picked the first character. No matter how much I type in, it only grabs the first character. You're right. I only get 1. Because that's what this is saying. You can think of it in Python, it's much the same way. Strings, arrays, lists, all of those can be thought of as an array type or a list type or whatever you want to call it. All right, back to where were we at here? I lost my thing. Oh, where did the Pizza Planet go? I must have closed him out accidentally when I was futzing with it. Okay, there's another new concept, getting character input. Oh, and then we're working with, see, our new menu system. Look at that, SML. We can do yes and no. Does that look professional? What do you think there, Andy? Does that look much nicer than 1 and 2? Yeah. So this deals with constants. It deals with characters and classes, because this declares an object. This is using the class directly because that's how it's designed to work. It's a wrapper around this primitive variable. All right, that was pretty neat stuff. That's what we're here for.